Hello and welcome to your first lesson in Unit 8. We are going to talk about scientific notation today. Before we proceed, I would very much like it if you had your classwork notebook out and ready so that you could take notes along the way. Before we begin, let's have a conversation about numbers that have exponents. I know we've worked with them before and you definitely have experience with them, but just as a reminder, the base is the big number. In this case, that would be the 5, and the exponent is the small number. It's the number that the power is raised to. So 5 to the power of 3, that would be 5 times 5 times 5, which is equal to 125. Your learning target for today is I can write numbers using scientific notation. So why do we use scientific notation? Well, it is actually a scientific method of writing very large numbers in a smaller format so that they're easier to add, subtract, multiply, and divide, or very, very tiny numbers, again, in a simplified manner to do all the math operations with them. So today we're going to be talking about large numbers and making them more manageable, smaller, and then very small numbers and making them bigger, again, to make them more manageable. Before we get into the actual process, it's important to understand the rules. So this page really focuses on the rules of writing numbers in scientific notations. So the decimal is very important. The decimal must be placed. It must be placed after the first non-zero number, okay? If you have extra zeros that are at the end of a number, they are not written. That is super important to understand. We use this times after our decimal number. And then we say whatever our movement was right here, how many times we had to move that decimal so that we had a non-zero number leading, that becomes a positive exponent if we are making a big number smaller, meaning the number is greater than 1, and a negative number if we're making a number that's a decimal larger. So the number is between 0 and 1. This has nothing to do with positive or negative numbers, just positive or negative exponents. So this is what scientific notation looks like. As you can see, we have the decimal right after the first non-zero number, so it's 1.457 times 10 to the power of 3, which means that this number was a big number to begin with, and we made it smaller. And then, again, we have our decimal point after our 5 times 10 to the power of negative 5, which means that this number, 5.29, was a very small number, a number between 0 and 1. So our first lesson is what we're going to be doing today. We are not going to be doing lesson 2 for, maybe a little over a week. So what we're going to do today is we're going to convert from standard form, that's a normal number, into scientific notation, and then back again to standard form. Always understanding to go backwards is the most important thing we can do because it really shows our understanding. This second lesson will be something that we work on later. We're going to start today with making our big numbers smaller. So we're going to go from standard form into scientific notation with numbers that are greater than 1. So if you take a look, step 1, we have this number here. We have 1, 2, 3, 4, 0, 0, 0, 0, 0. So what we want to understand is where the placement of the decimal lies in a number like this. In a number like this, the decimal is always right here. It's implied that it's there, but we never write it that way. So the first non-zero number, it says, what is the first non-zero number? It's this number 1 right here. And we need to move our decimal all the way over there. So we're going to be moving it. And if we're like kind of counting this way, that's what we want to do. So if you counted all of these, it was 7 times that we moved that decimal over. And then the next thing we're going to do is we're going to write the number with the decimal, and we're going to leave off all of the zeros. So do you see all these zeros right here? They're going away. So it becomes 1.234. There's your decimal right there. And then we add this multiplication symbol, and it's always a base 10. And then this is our exponent, number 7, because that's what we raised our, that's how many times, we moved our decimal point. So 1,234,0000 becomes 1.234 times 10 to the power of 7. Okay, so what I would like you to do right now is I would like you to pause this video, write down every single number here, and work on them in your classwork notebook. And then I would like you to come back and check your understanding with what I'm going to do. All right, so welcome back. So converting from standard form to scientific notation. The first thing that we want to do is we know we have a decimal here. We're going to move it 1, 2, 3, and 4 times. So this becomes 3.4907 times 10 to the power of 4. So we have our decimal here. We're going 1, 2, 3, 4 again. 1.9593 times 10 to the power of 4. Our next one, where our decimal is, our decimal is right here, and we're going 1, 2, 3, 4, 5, 6, 7, 8 times. So we end up with 1 point, let's see, 1, 2, 3, 4, 1, 2, 3, 4, 3, and then no more zeros, times 10, I think it was 8, I'll count again, 1, 2, 3, 4, 5, 6, 7, 8, 10 to the power of 8. All right, moving on. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to write that down right there. So that becomes 4.2909 times 10 to the power of 9. Decimal 1, 2, 3. 1 times 10 to the power of 3. That would be 1,000. And last but not least, 1, 2, 3. We have 5.729 times 10 to the power of 3. Hope you did well. All right, so we're going to take a look at these numbers, and we're going to see if they're written in correct scientific notation. Let's take a look at our first one. So if we look at our very first one, we can notice that our decimal right here is not after the very first non-zero number. So we are going to have to move that one more place. So we're going to be adding 1 to the exponent. Our correct number would be 3.429 times 10 to the power of 4. Let's take a look at this one. This is not correct either because our decimal is here. We have to move it 2 more times, so we're going to be adding 2. So we're going to have 9.29 times 10 to the power of 6. This one, we are missing something in between here. 1.32, we're missing our multiplication. All right, here we go. Keep going. This is correct. Well done. How about this one? This is technically correct, but you could simplify, right, to be 2.91 times 10 to the power of 8. More semantics than anything else. And last but not least, obviously we need to move 1, 2, 3, and 4, so we're going to add 4. So we have 3.8901 times 10 to the power of 12. How did you do? Let's take a look at our little numbers, our values that are between 1 and 0, so our decimals. We are going to represent them again, like we had talked earlier, by a negative exponent. Remember your rules for negatives, right? When you add negatives, they become more negative. Let's keep going. Small numbers in standard form to scientific notation. So the rules are pretty finite. We want to move this decimal so that it's after that first non-zero number. So we're moving 1, 2, 3, and 4. We are moving negative 4 because we're making a small number larger. So we're going to rewrite it as 7.86 right here. And we get rid of all those leading zeros. And then what we do is put our times and negative 4. Let's practice. Just like before, I would like you to write down all 6 of these values. I would like you to work on converting them from standard form to scientific notation and then come back and check. So welcome back. So we want to move our decimal for this first one, 1, 2, and 3 places. So we're going to write it as 3.56 times 10 to the negative 3, and that tells the reader that this number originally was a small decimal. We're going to move 1, 2, and we have 7.8 times 10 to the negative 2. You'll notice that we got rid of these zeros and both of those. Moving on, we're going to move 1, 2, and 3 again. So we have 2.19 times 10 to the negative 3. Lots of movement here. We're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to write down negative 9 so I don't forget. 9.23 times 10 to the negative 9. Moving on, 1, 2. We're going to have 2.8291 times 10 to the negative 2. And last but not least, 1, 2, 3, and 4. So we have 3.4 times 10 to the negative 4. I hope you did well. So again, write these down. See if you do it right. We're trying to see if they're correctly written in scientific notation. So come on back when you're done. So welcome back. You can see that our decimal should be here, and it is not. So we are going to move it one more. We are going to be subtracting one more. So we have 2.85 times 10 to the negative 7. Be careful with that. We are going 1, 2, and 3, but it's minus 3. So we're going to have 4 times 10. 4 minus 3 is 1. You can write 1, but we typically do not write 1. This one again is missing our little x, and we should not have that. So we're going to have 1.32 times 10 to the power of 4. All right, moving on. 1, 2, and 3, so 3 more negatives. So we're going to have 2329, I need to put my decimal point in there, times 10 to the negative 7. And this looks pretty good. We just want to get rid of those, and we want to get rid of those. So let's just rewrite it. 2.78 times 10 to the negative 3. And our last one, we're going to move 1, 2 negatives, so minus 2. So we have 1.84 times 10 to the power of 6. I hope you did okay. These can get kind of confusing once you start to add that negative value in the exponent. All right, thank you for joining me. Please go back to your to-do list and keep moving forward. If you have any questions, please let me know.